You set your cruise control once, take your foot off the accelerator, and somehow your car keeps exactly the same speed. So how does it know what to do? Many people think cruise control simply locks the accelerator pedal in one position. But that's not how modern systems work. If the accelerator stayed fixed, the car would slow down uphill and speed up downhill.
Something much smarter is happening instead.
Cruise control constantly measures the vehicle's actual speed, compares it with your selected speed, and decides whether more or less engine power is needed. Everything begins with wheel speed sensors. They continuously report how fast the vehicle is actually moving. Inside the control computer, your selected speed becomes the target. The current speed is checked against that target many times every second. Now imagine the car reaches a hill. Gravity begins slowing the vehicle, and the computer immediately detects that the actual speed is falling below the target. Instead of waiting until the speed drops too much, the computer gently opens the electronic throttle, allowing more air into the engine to produce additional power. As more air enters the engine, the control system adds the correct amount of fuel. The engine produces just enough extra power to maintain your selected speed. This process never stops. The sensors report the new speed, the computer checks the result, and the throttle is adjusted again if necessary. Now the situation reverses. Gravity starts helping the car, causing the speed to rise above your chosen setting. The car's systems engage. The control computer immediately reacts by reducing the throttle opening. Less air means less engine power, preventing unnecessary acceleration. The goal isn't to make the speed absolutely perfect every millisecond. The goal is to keep it extremely close to the target using hundreds of tiny corrections. Older vehicles often controlled the throttle with cables and vacuum actuators. Most modern cars use electronic. Every time you press set, resume, or cancel, you're simply giving the computer a new instruction. From that point on, the control system handles the rest automatically. Whether the road rises, falls, or the wind changes, the computer constantly recalculates the exact throttle position needed to keep your speed nearly constant. Cruise control has limits. If the hill becomes too steep and the engine reaches its maximum power, the system simply can't create more acceleration. Modern adaptive cruise control goes one step further. It doesn't just maintain your speed, it also monitors the traffic ahead and automatically adjusts. Radar and cameras continuously measure the distance and relative speed of vehicles ahead. The control computer uses this information. Depending on the vehicle, adaptive cruise control may reduce engine power, apply gentle braking, or combine both actions to match the speed of traffic ahead. As soon as the lane clears, the system smoothly accelerates back to your preset speed without any sudden movements. The moment you press the brake pedal, cruise control immediately disengages. Safety always takes priority, and the driver remains fully responsible for controlling the vehicle. In simple terms, cruise control works by constantly measuring your speed, comparing it with your target, and making hundreds of tiny throttle adjustments. Cruise control isn't holding the accelerator still. It's constantly thinking, measuring, and adjusting to keep your speed remarkably consistent.